Hi everyone. It's a real pleasure to be able to speak to you at the Lovelace Colloquium. I know we're all enjoying it from our homes instead of in person this year, but it's great to see Hannah and the Lovelace volunteer team put on the event despite the challenges of 2021. A massive well done to her and the team. So when Hannah invited me to speak with you today, I wanted to pick a topic which was getting a lot of attention in industry at the moment, but maybe not getting talked about a lot in your classes right now. And to me, that's the subject of data engineering. So today I'm going to give an overview of what data engineering is, what makes data engineering an exciting field to be in, and what you should do next if you were interested in the subject. So before we get started, a little bit about me. So I did my computer science degree at Edinburgh University about 20 years ago now, which is a long time. And since then, I've worked in various large and small organisations, including the Scottish Government, Sainsbury's Bank, Skyscanner as well. Recently, me and a friend have started a new legal tech startup called Valla, and our mission is to make legal support simple and affordable. I won't be talking much about Valla in this talk, but if you're interested, please ask me about it in the Discord channel. So, on to today's topic: what is data engineering? And more importantly, why should you care? So, you might have seen a few of these headlines: data is eating the world, data is the new oil, data is king, and followed by my favorite: data is the new bacon. So, with more and more companies using machine learning and big data as a way to create personalized services, you might have heard that the demand for data scientists has been on the rise. But did you know that in order for a company to be data driven, you need more than just data scientists? You actually need data engineers. So, in the DICE 2020 Tech Job Report, data engineer is actually one of the fastest growing job roles out there. So, why is this? What job does a data engineer do? So, imagine you work in a company. Your data scientists need to be able to see what users are selecting and when, so that they can make improvements to the personalization algorithms. So you got data analysts who need to see what people are buying in order to be able to make a prediction on the company revenue for the year. And you got your commercial managers who might need to know which products are doing best so that they can make better deals with your suppliers. Now, all of those people in the company, and there are many more than just data scientists, data analysts, and commercial managers, but all of those people need similar data and information, but they might need it in a slightly different level of detail, or might want to see it in a slightly different way. Now, what data do you have? You might find that the data is actually coming in as a CSV file from your suppliers, or via logging events from your backend servers, or from a third party tool like Google Analytics. And if you work in a large enough company, you will normally have a combination of all three of them. And your job as a data engineer is to bring in new data into a company, process that data, organize it, and store it ready for use. Data is the new oil. It's valuable, but if unrefined, it cannot really be used. It has to be changed into gas, plastic, chemicals, etc. to create a valuable entity that drives profitable activity. So data must be broken down, analyzed for it to have value. So what makes data engineering an exciting field to be in? The answer is there's a huge variety in the work that you get to do. So I'm going to name 3 examples of this. So example 1, you get to work with external companies and internal teams to bring data into the data platform. So when I've worked with data teams in the past, we've often had to work with data teams in other companies, especially if they're someone we're partnering with. So we have to talk to them about which file formats to bring in the data, how often, is it hourly, daily, or weekly, and where to put the data and where we can pick it up. It's actually really fun to be able to work with other data engineers in other companies to do this, and we get a chance to really talk and understand how they work as well. And when we work with external companies, we also have to figure out how they're structuring their data output and how it maps onto our existing systems. So when they're talking about storing someone's name, is it the same way that we store the name? And do we need to transform or do anything to those data fields in order to be able to store the same information on our system? When they have specific metrics, is it the same way that we calculate those metrics? And one of my favorites is talking about time zones. How do they store their information and by what time zone? And then you've got working with internal teams. So data engineers often work with other software engineers to agree what events should be fired to track user behavior. So if you think about, also you have to think about the metadata that needs to be tracked. So which device are they on, which browser are they using, and which country are they in? And if you're working with multiple teams in a big company, how do you make sure that all of the teams that are tracking countries are using the same list of countries? Very complicated, but very interesting. Now, example 2. Once you've worked in bringing in that data into the platform, then you have to work with the data consumers to understand how best to structure that data to make it easy for them to use. This is a real issue when you've got a data platform with lots and lots of tables. But before we get to that, let's just take quite a simple example. Let's say you work in a company where users register for your service on the web and on a mobile app. You might use something like Google Analytics on mobile, and you might use Firebase on your mobile app. So for every user that wants to know how many registrations they have to join the registration events from the mobile app and the web apps together. Now, different users might join those tables using slightly different criteria, meaning that they'll get slightly different answers. Or you might find that 100 people in the company want to know what yesterday's registration numbers were. And as a result, this database union, this SQL join will be done 100 times every morning. So it makes sense to create an overall registration table for people to use. Now let's take a slightly more complicated example. Let's say you have a table of sales figures. And this table has a row for every single sales ever made inside your company. So searching through this table takes a huge amount of time because it's made up of billions of records. And not only is it slow to search through, but it takes a lot of computational power to do this. After talking to a number of people who use this table, it turns out that 60% of them want to see how many sales were made yesterday compared to the day before. So think, I'll just create a daily sales table. And every night, overnight, when no one's using the system, you will have a data transformation job that just counts up how many sales were made and adds a new record to the daily sales table. Now, another 20% of the users use the big sales table to find out how many sales were made by an individual customer. That is, for each customer, how many sales were made. Now, this is quite a big job. So you create a data transformation job that counts up how many sales there are for every customer ID that there are. Now, with the remaining 20% of the users that use the giant table, they mostly use it to look up monthly sales. Now, they could use the daily sales table that you've created, so that's one option. But at the end of every month, you'll have lots of people using the daily sales table, and you might be quicker to just create a monthly sales table that they could use. Also, as part of talking to those users, you find out that some of them actually deal with individual suppliers and they want to see monthly sales by each supplier. So, if you imagine the sales data you had at the start as that raw data, through the act of talking to your customers, as in talking to your users that use that table, you now understand what they actually use that data for and can now create tables for them that make their lives much, much easier. Now, lastly, is that I think in data engineering, there's some really interesting hard problems to solve. So if you work for a big company, there's a question of how do you deal with millions of events per second? So as an example, in Netflix, they were dealing with up to 8 million events per second. And at Skyscanner, where I worked, we had the same issue, which is millions of events are being recorded. How do we process that data, store that data, and make sure that our platforms are reliable? Now, if you think back to the sales slide, every time a new user looks at the data platforms, there are now 5 different sales tables. So how does a user navigate through those tables? How do they get started? How to help them to understand what's there and how to use it. They might want to know, where's this data from? What detail does it contain? Is the information aggregated into daily, weekly, monthly level, or is it stored at a per event level? And who has access to this data? And part of the challenge is to design consistent naming conventions to help users navigate through all the tables that might be available. And my favorite analogy around this is like, how do you organize a lot of books in a library? Without a numbering system like the Dewey classification system, it can be quite overwhelming for any new person coming into the library to try and find what they need. Last thing, data quality. How do you make sure that if bad data comes in, that you catch it in time? How do you know what to set as the upper bounds of what's acceptable and what isn't? So when I was at Skyscanner, we saw a flight event that was purchased for $12,000. Now, is that real? Could $12,000 be a first class ticket? Or is it someone testing the system? A lot of that involves talking to other people to find out. But you've got to catch it in time. If someone was testing the system, such as a front-end developer, then you can actually understand what was going on. Another inverse of that is what happens if you have an absence of data? So when something is being broken on the front end and it's not being recorded properly, how do you catch that? So I hope that I have demonstrated to you that there are some really interesting challenges in data engineering, and it makes it quite a new and quite exciting field to be in. So you're thinking, well, okay, I'm interested. So what do I do next? So now there are a number of new courses coming out. So this is Udacity has a course around data engineering. Coursera has a number of courses around data engineering as well. And both Google Cloud and AWS have their own big data speciality and certifications. So you should definitely look into those. Another thing you could be looking into is around database modeling and the different types of models there are. So there's, for instance, first normal form, second normal form, and third normal form. But other patterns, such as The Snowflake, the Star Schema, and the Data Vault are very interesting patterns to look into. And lastly, it might be worthwhile looking at a number of the technologies that are being used. For instance, there's Hadoop, Apache Spark, Great Expectations, which is for data testing, and dbt, which is the tool for data transformations. It's out with the scope of this talk to talk about the details, but definitely go and look them up. So with that, thank you for listening, and please head over to Discord to ask questions. Thank you.